Math 242 Quest to College. I'm Joe Vasta, and today we are doing section 6.3, Exponential Equations. We're solving equations where the variables are in the exponents. Now, we've already done this before. We've done problems like this. So, especially this one right here. What you want to do is see if you can get a common base. So that's what we're going to do. Common base of here of 27 and 9 looks like it could be 3. So go ahead, pause the video and see if you can do this problem. 3 squared, that's 9. And 27 is 3 to the third, or 3 cubed. Okay, I have a power to a power, so I'm going to multiply. 3 to the 8x equals, I'm going to multiply that one too. So this is going to be 3 times 1 minus 2x. So this is 3 to the 8x. I'm going to distribute that 3 over there. So this is 3 raised to the 3 minus 6x. Now I have 3 to this equals 3 to that. So I'm going to go ahead and take this and set it equal to that. 1-to-1 property of exponential functions tells us that we can do that. And now I'm going to go ahead and solve for x. I'm going to add 6x to both sides. I'm going to divide by 14. So x is 3 over 14. There's your answer. This right here is a type 1 exponential equation because we were able to get a common base. Let's go ahead and solve some more. So in 6.3, all you're doing is solving exponential equations. There are some applications coming later on in chapter 6. So right now you just have to just get through the math and see. Let me check how clear it is. It looks pretty clear. Go ahead and do problem number 2. This guy right here is not type 1 because you can't get a common base between 2 and 3. We call this type 2. With type 2 exponential equations, we're going to do something that we did in 6.2. We are going to log both sides, and I'm going to ln both sides. Your book will use the ln, so I'm going to keep with what your book is doing. You ln both sides of the equation. Okay, by doing that, now we can use the power rule of logs to make that guy jump in front of the logarithm. So I have 5x ln 2 equals ln 3. Now I'm trying to solve for this x right here. And he's got 5 multiplied by it and then this other number. So what I'm going to do is I'm going to divide both sides of this equation by 5 ln 2. 5 ln 2. And so, of course, these guys right here are going to cancel. I'm going to have x equals ln 3 divided by 5 ln 2. This right here is called an exact answer. Okay? So this is an exact answer. Are there other techniques of doing these? A different teacher may say, hey, change this to log form and then use property 8. So there's more than one way to get these problems done. But with this way where you ln both sides, it could help us when the problems are a little bit crazier. I brought up this exact answer thing is because what we might want to do, you know, like in the real world, is tell somebody, like, what is this? Maybe this was the answer to something important. And so a lot of people will put this in their calculator and they'll try to do it all in one thing and they'll forget to put parentheses around the whole denominator. If you just put this in your calculator like this, ln3 divide by 5 times ln2, order of operations says it will do the division first and then multiply ln3 over 5 by ln2, and you will get something that's wrong. So what you want to do if you're going to put this in your calculator is put parentheses on the bottom. Now I believe your book doesn't ask you to do that on here, but I'll go ahead and do this. And what I'm getting is 0.316999. And the deal is, you have to round sometime. When you get an answer like this, this is called an approximate answer. And there's a time and a place for approximate answers, and a time and a place for exact answers. I'm going to check something out on my calculator really quickly, make sure that I got the right answer. What? Okay, I think I probably did that right. So 0.31, and then multiply that answer by 5. And I'm going to go 2 raised to that power. So what I did is I took this answer and I plugged it back into this equation in the calculator, and I ended up getting exactly 3. Okay, so let's go ahead and solve some more type 2 exponential equations in your homework. Most of them will be type 2, but there will be some type 1s. Could I ln both sides of this? Yeah, I'm going to have some logarithms that could be simplified, and if you're done simplifying them, you would end up getting 3 over 14, which is a longer way of doing a type 1. So type 1, you want to do it without logarithms. Okay, problem number 3. Oh, by the way, another thing that I probably should point out is this equation. I'm going to refer to this equation, I don't think your book has this, as a basic exponential equation. Because it says something to a power equals a number. So the question here on problem 3, is this a basic exponential equation? Well, we don't have 100 to the power. The order of operations says it's just 3 to that power, and the 100 is just sitting there. So this is not a basic exponential equation. Probably the first thing you want to do is make this into a basic exponential equation before you ln both sides. So I'm going to pause it right now and see if you can do the problem. And then why don't you pause it? I don't think I can pause it. Okay, I'm going to divide both sides of this equation by 100. And then I have 3 raised to the x minus 2 equals 5. I'm going to ln both sides of this equation. And now I'm going to use the power rule of logarithms and make this power jump out front. I'm going to write this down incorrectly, and maybe you can see what is wrong. This is a common thing people do. The incorrect thing is the fact that this power here, what used to be a power, should have parentheses around it. Okay, the next thing that I'm going to do is I'm going to go ahead and distribute the ln3. Well, there's a few ways. We could divide by ln3 and then do that, or we can distribute the ln3. Why don't I go ahead and divide by ln3? So I have x minus 2, because those guys cancel, equal ln 5 over ln 3. Solving for x, so I should add 2 to both sides. Now, 2 is not going to gel well with that ratio of irrational numbers, so I'm just going to put it after. So x equals ln 5 over ln 3 plus 2. So this right here is an acceptable answer. Now, when we had this right here, so we're done. So probably I shouldn't have to do this, but I'm going to do this anyway because I mentioned it and I don't want people to think, well, what was he going to do before? So this is just another way. I'm going to distribute the ln3. It's like a number. I'm going to distribute it in. So this says ln3 times x minus 2 times ln3 equals ln5. So already people are like, I don't like this way. I'm trying to solve for x. So I'm going to add this term to both sides. So I have, let's just write it as x ln3. I should have done that. This is going to be ln5 plus 2 ln3. And then I'm going to divide both sides by ln3. So I have x equals ln5 plus 2 ln3 all over ln3. Now that you might say, well, we got a different answer. But if you split the fraction and write this as ln, so this is a legitimate answer. This is good. But just to show you that it's the other answer, split the fraction. Those cancel, and you have ln5 over ln3 plus 2. Okay, let's go ahead and do the next problem. This is another type 2 exponential equation. It's not basic because it doesn't say something to a power equals something. It's 10 times something to a power equals something. So see if you can do this problem. Okay, I'm going to divide both sides by 10. And I have e raised to the negative 250x equals 1/5. The next thing I'm going to do is I'm going to ln both sides. Ln e to the negative, oh, it just got darker, so the clouds are covering up the sun. Hopefully it's not ruining this video. Oh well, the video's already ruined. It's a bunch of math. Can you imagine someone not in this class, not taking a math class anywhere, coming and watching this video? They must have, I can't even imagine it. I'm out of words to think about that situation where someone just comes and watches these things for entertainment. But anyway, so this guy is log base e of e to this. Now we can jump that in front and have an ln e and that becomes 1, or we could just say that this thing goes pop. I think that's like property 3 or something. So this is negative 250x equals the ln of 1/5. So I'm solving for x. I'm going to divide both sides by negative 250. So x equals ln 1/5 divided by negative 250. Now some teachers will frown when they see a negative on the bottom of a fraction, but if you don't like your next math teacher, that's something you want to do then. I mean, if I were a good math teacher, I'd put the negative up there. So that is what we have, and lots of times when you do logarithms, you look in the back. So here's the book's answer, maybe. I'm just kind of making this up. But they might have something like this. ln 5 over 250. Okay, so, you know, that, when that happens in math, and that happens more than you think to people, it's like, I don't know, it's just like crying, like it's like puddling up there. So we're crying because I hate when you work really hard on a problem and the book's answer doesn't, it looks kind of like your answer, but it's not the same thing. So what I'm going to show you is probably how the book got that. Now I should probably do it in blue. On the top you have a quotient. This is a good answer, so keep it this way, but if you're trying to verify the book's answer, you could do this. The quotient rule tells me ln1 over, ln1 minus ln5. This is all over negative 250. If you remember, I think it's property 1. Yeah, it's probably property 1. With a log of 1, that's just 0. So this gives me negative ln 5 over negative 250. The negatives cancel, and you get ln 5 over 250. So yeah, the book's just doing some of these things sometimes because they're like, yeah, there's too many people going into the technical world. We want less of those people, more English majors, history majors, so they go ahead and do something like that. And so yeah, it's motivation, I guess. Let's go ahead and do problem number 5. See how we're doing with time. We're into this 16 minutes. Is this a basic exponential equation where it says a base to a power equals a number? No, this is a mess. And in certain applications that we might see, we might look at something that looks like this. So what we want to do is multiply both sides by the LCD, or put this 1000 over 1 and do a cross multiply. It's kind of the same thing. So I have 400 equals 1000 times quantity 1 minus 2e to the 5t. Okay, I'm trying to solve for t. That's what I'm trying to do, and really what I'm trying to do is I'm trying to solve for that guy right there. That's what I'm trying to solve for. I notice that there's some zeros here, so I could actually divide both sides of this equation by 10. And that will get rid of one of those zeros and one of those zeros. I might as well divide both sides by 100. And so this will give me 4 equals. This is just a preference. You could have not done this and distribute the 1000 through whatever, or divide both sides by 1000 if you want it. 4 equals 10. 4 does not equal 10, but 4 equals 10 times 1 minus 2e to the 5t. We could have actually done better and did a better job and maybe divide by 200 instead of 100. So 2 equals 5. 1 minus 2e to the 5t. Okay, I'm going to distribute that 5. So we have minus 10e to the 5t. What I'm going to do now is I'm going to subtract a 5 on both sides. So negative 3 equals negative 10e to the 5t. I'm going to divide both sides by negative 10. And I'm going to continue up here, switching things around as well. E to the 5t equals 3/10. So we didn't even do any logarithms. All we were trying to do throughout this whole problem was solve for that. I mean, you could replace that green thing like with a W, and it was just some algebra. Now I'm going to ln both sides of this equation, ln e to the 5t equals ln 3/10. And what happens on the left-hand side? Well, on the left-hand side, that thing goes pop. You have 5t equals ln 3/10. You could put 0.3 there if you'd like. I'm almost done solving for t. Going to divide both sides by 5. And I have t equals ln 3/10 over 5. Now, if you wanted to make this problem, the answer, not look as bulky, you could. This is a style thing. Write it as 1/5 ln 3/10. And so that's what we can do. And I believe on another problem, maybe it wasn't on another problem. Oh yeah, we could have done that on problem 4 and write negative 1 over 250 times the ln of 1/5. Well, any case, those are both the same. Let's move on to our next exponential equation. So problem number 6. I think we have like 3 more to do, and that will cover 6.3. Problem number 6 we have, well, this is pretty confusing because we don't have a simple exponential equation. We do have this 5 and this 40, so maybe we should divide both sides by 5. So I have e to the negative 2x equals 8e to the 3x. So there's a few things I can do. I might come back and show you another way to do this problem. But what I'm going to do now is, since these are both e to something, I can't put them together, but on the left-hand side, I can write 1 over e to the 2x. This equals 8e to the 3x. So this is something that I can do. Now I'm going to multiply both sides of this equation by e to the 2x. So I get a 1 on the left-hand side, and on the right-hand side I get 8. And I'm multiplying these guys together. I should add their exponents, so this is going to be 8e to the 5x. That's 2x plus 3x. I'm going to divide both sides by 8. I'm going to go ahead and write it like this. E to the 5x equals 1/8. That's a matter of style. And then I'm going to ln both sides. ln e to the 5x, which you know that thing's going to go pop. And then we have ln 1/8. So where's the color that I did that pop? I have 5x equals ln of 1/8. And so I'm kind of bringing it over here. X is going to equal 1/5 ln of 1/8. Now the book will probably write this as negative 1/5 ln of 8 because they'll do a quotient rule here, ln1 minus ln8. This is good enough. But just be aware when you're checking your answers that sometimes the book may have a different looking answer, and it's just properties of logs. So let's go back to this right here. And most of you are not going to like what I'm going to do, so just take the little tab on the YouTube and keep going forward quickly until you hit problem number 7. So for those of you who are going to hang around, which are probably like nobody, I'm going to ln both sides of this equation. So I have the ln. This is just another way. ln e to the negative 2x equals ln 8e to the 3x. Okay, on the left-hand side, that thing goes pop. We end up getting negative 2x. On the right-hand side, you might think, oh, something goes pop, or the exponent jumps, but the exponent cannot jump because that 3x is not the exponent for the 8. This right here is a product. So I'm going to write this as ln 8, using the product rule, plus ln e to the 3x, which now can go pop. And so I have negative 2x equals ln 8 plus 3x. I will subtract the 3x on both sides, and I will divide by negative 5. So I'll write this as negative 1/5 ln 8, which is a good answer because we said, like on this one right here, this could equal 1/5 ln 1 minus ln 8. And then this guy right here, ln 1, is just 0. So it's the same answer. Okay, let's go ahead and do the next problem. This problem right here is not a basic exponential equation like we've been looking at, where something to some power equals a number. Now this is something, a base to a power equals another base to a power, and unlike the last problem, those are not the same bases. So what I'm going to do on this problem is I'm just going to start off by ln'ing both sides. ln 5 raised to the 1 plus 2x power equals the ln of 2 raised to the 3 minus 6x power. Okay, I'm going to go ahead, I'm solving for x here. I'm going to make the 1 plus 2x jump in front using the power rule of logarithms. And maybe you can tell me what I did wrong there. What I did wrong is I didn't put parentheses. I'm going to also do the same thing over here, making sure I put parentheses. Okay, now I have to solve for x, and this is going to be a complete mess. So what I'm going to do is I'm going to say ln 5 is going to be equal to some number a. And I'm doing this so I don't have to write all those symbols every time I write that one number ln 5. You don't have to do this substitution thing. I'm going to do the same thing. That's what I'm doing. I'm doing substitution. I'm going to let ln 2 equal b. And now I don't have to keep writing logarithms, and I'm going to solve for x in this by first distributing the a and b into those parentheses. So this is a plus 2ax equals 3b minus 6bx. I'm trying to solve for x. Those are my x terms, so put them all on the same side. I think I'm going to put them on the left side, so it says 2ax plus 6bx. This is going to equal, I'm going to subtract a and put him on the right side because he does not have an x. So this is 3b minus a. So now I have all my x terms on the right hand side. I'm trying to solve for x, so I'm going to, what does that look like? I'm going to factor out an x. Minus a. And then I'm going to divide both sides by the 2a plus 6b. 2a plus 6b. And what's going to happen on the left-hand side is those guys are out of there. And I have this expression, 3b minus a over 2a plus 6b. Well, b, remember what b is. B, hopefully this won't smear. It's smeared. Great. B is the ln of 2. Might as well just make it all smear now. And a, wait, I can't use orange. I'll use blue. Hopefully it doesn't. Okay, a is going to be the ln of 5. So I'm going to go ahead and replace those. So 3b, 3, and then we have the yellow part, ln 2, minus a, so minus ln 5, all over, I'm just writing this fraction right here, 2 times a, 2 times ln 5, plus 6b, plus 6 ln 2. And here's a legitimate answer. Sure, hopefully the book doesn't bring that 3 up there and write that as ln 8, and then actually do the, no, we don't want to talk about that. So this is a good answer, and this is actually a lot harder than some of the other problems that we've done. Checking our time, we're at the 30-minute point. So why don't we go ahead and do our last problem of 6.3. Right now I'm getting that feeling where I really want to push the red button in the classroom. I just keep looking at it every time I close my eyes, and I should have pushed it when we were all together in class. And now I'm always going to regret that. So look back on my life, and maybe on my deathbed I'll be like, I should have pressed the red button. So that is, I do miss coming to class and doing this in front of you guys. I hope that these videos are at least carrying some of you through the semester. It's very tough times we're going through. Let's go ahead and do, and the times are going to get tougher because of problem 8. Let's go ahead and do this problem here. This looks really bad. We cannot put those together. I mean, we can't change base when it's looking like this. So what we're going to do is we're going to kind of do a trick. This 9 is really 3 squared to the x. Okay. Plus 3 to the x equals 20. So this problem is going to be kind of intense like the last one. Now, when I do this, I could just multiply those exponents. This is 3 raised to the 2x plus 3 to the x equals 20. Now I'm going to do something unexpected. I'm going to write this as 3 to the x squared. It's almost like those guys switched places. We could do that. Everything is legal that I'm doing here. Now, what I'm going to do is I'm going to do a substitution where these guys right here, I'll pick a letter, and the letter cannot be x because that would kind of confuse things. I'm going to pick w, and I'll change colors. W squared plus w equals 20. So that is what I'm going to solve this quadratic equation. I actually did a substitution. This whole idea of substitution is an important thing for calculus. Sometimes what you're doing is you're kind of going undercover and tricking the equation into being solved. See, now that's not an exponential equation. We've tricked the equation into being a quadratic equation. Hopefully we do not have to use the quadratic formula. I'm going to put everything on one side. Factors of 20 that subtract and give you 1. Oh good. 4 and 5 should work on that. So this is w, 4, 5. Let's see, we want the minus to be with the 4. So I have w minus 4 equals 0. W plus 5 equals 0. W equals 4. W equals -5. Wow. So let's write that up here. W equals 4. W equals -5. Now the W is not what I was solving for. I'm solving for x. So I'm going to replace those W's with what? Well, the W, we're going to smear the ink again perhaps. Those W's were 3 to the x's. Okay? So this is 3 to the x equals 4, and over here it's 3 to the x equals -5. 3 to the x equals 4 is now just a basic exponential equation. I'm going to ln both sides. I'm going to use the power rule, bring the x out front. Just got darker again, those clouds. I like days like this where the clouds block off the sun and then the sun comes out, but when I'm doing a video, I don't know about that. I guess it's cool. Okay, so look what happens. X equals ln 4 over ln 3. Let's go ahead and ln both sides of this one. ln 3 to the x equals ln negative 5. So there's a problem right here. The argument is negative, which is bad. That means you can't do that. So this road right here that we're taking, this is a dead end. Another way you can see that this is a dead end is if you have 3 to the x, which is the airplane taken off, I'm talking about graphs, will that ever have an altitude of negative 5 when you graph that 3 to the x function? No, it never will have an altitude of negative 5. It will never be below the x-axis. A lot of you probably did not like that explanation, but just remember, if you have an ln of a negative number, game over. So if you've got no solutions coming from there, and you got one solution coming from there, then our final answer is going to be this one solution. So we are done with 6.3. You guys take care of yourselves, and I'll see you in the next video.